Have you been on a boat or a ship, like when you went to another island for a vacation or a visit to your relative or a friend? Or when was the last time you went to a beach for a swim? In both scenarios, have you noticed the waves on the sea? Were the waves high or low? Were they gigantic or small? Recalling such experiences is fun, right? I am showing you here a video clip of big waves smashing through the seawall. Have you seen such a scenario before? You might have seen it personally or on the weather news, right? What can you say about it? Well, it would not be good if you're riding on a boat or wading on the shore while the waves are behaving violently, right? This time, we'll look at the science behind those waves that you might have enjoyed during summer in your favorite beach resort or you witnessed when the air in the beach was strong. Hello class, I am Kerby Tacorda, a BS Mathematics and Science teaching student from the University of the Philippines, Los Baños, and I am one of your science teachers here in the Filipino Science Hub. In this lesson, we are going to talk about waves, what it is, its nature, what are its characteristics, wherein we're going to focus on two, amplitude and wavelength, and finally, the relationship of these characteristics to energy. I hope that we're ready to learn the science of waves, feel the waves while seated, and enjoy the science behind. If we're ready, let's first have our learning objectives so that we won't get lost along our way in this learning journey. After this lesson, the student should be able to understand the concept of waves, describe the amplitude and wavelength as characteristics of waves, relate amplitude and wavelength to the energy of waves, and lastly, infer that waves carry energy. Before we start, let's take a look at a pretest I prepared for you. You can take a screenshot of it or you can write it on a sheet of paper. You can also try to guess the answer, and at the end of the video, we will see if your answers were correct, right? You do not have to worry about wrong answers for now because it would serve as an overview of what you're going to learn from this lesson. Alright? Number one, it is a disturbance moving away from a source and carrying energy with it. A. Vibration. B. Wavelength. C. Wave. And D. Frequency. Number two, what do you call the undisturbed position of particles in the absence of vibration? A. Energy. B. Wave. C. Amplitude. And D. Rest position. Number three, what does the red line represent? A. Wavelength. B. Amplitude. C. Rest position. And letter D. Vibration. Number four, which of the two figures has a lower energy based on wavelength? Number 5. Which of the following lines does not represent a wavelength? Number 6. True or false? We can only measure the wavelength between two successive crests or between two successive troughs. Number 7. True or false? In this figure, the red line represents the amplitude of the wave. Number 8. True or false? Waves carry energy with it, which is indirectly proportional to its wavelength. Number 9. True or false? Waves carry energy with it, which is directly proportional to its amplitude. And number 10. True or false? Waves carry matter from the place of origin into its destination. I hope that you participated in our pretest. Now let us start learning and finding answers to the questions we just encountered. Alright, so what is a wave? A wave is a disturbance moving away from a source and carrying energy with it. And I want us to have a focus on what disturbance means, okay? I have a basin here with enough water. And as you can see, the water is not moving and waving. It's still water. But if I drop a coin to the water, It creates ripples, right? It creates waves. Why? Because I disturb the water when I drop the coin. The coin serves as the source of disturbance such that the water ripples, hence the waves, are generated as a result. Now that we know what a wave is, we can now proceed to its characteristics. In this part, we will focus on two basic characteristics of waves, amplitude and wavelength. Let us begin with amplitude. Amplitude is the maximum displacement from the resting position to the top of a crest or to the bottom of a trough. We will digest this definition, okay? Now what I am showing you is a typical representation of a wave. I want you to have a good look at it because you will encounter this drawing a lot of times, okay? This line in the middle, the center line, is what we call the resting position or rest position. Okay, this serves as a reference line which represents an undisturbed medium where there is no vibration, no wave. All right, and just like sea waves, we have the highest and lowest points in this figure, right? The highest points are what we call crests. On the other hand, the lowest points are what we call troughs. Now, going back to the rest position, we know that amplitude is the maximum displacement from the rest position to either the crest or the trough. This is the resting position, and when we draw a line from here to the top or from here to the bottom, then this is the longest line that we can draw without passing through those points, right? And the line we just drew is the amplitude. It is the longest line that we can draw, which only means that this is the maximum displacement or pinakamahaba na pwede nating i-drawing mula sa rest position papunta sa crest o mula sa rest position papunta sa trough. Can you follow, class? Great. We draw a line again from the resting position to this highest point, then we have an amplitude. We draw a line again from the resting position to this lowest point, then we have an amplitude. Right? Now let's relate this information in real life. I am showing you here a series of waves. Which do you think has the highest amplitude? The answer is letter A, right? And how about the lowest amplitude? It is letter C. Okay, good job. Remember this figure, class, because we will use this again later, alright? Another very important characteristic that we need to understand is wavelength. To define it, a wavelength, which has a symbol of Greek letter lambda, is the distance between two successive crests or between two successive troughs. Again, I am showing you the figure I just showed you when we discussed amplitude. We know that this point is a crest, right? And this point is also a crest. And we say that these two are successive because one follows the other. Also, the lowest points are what we call troughs, as indicated here. Now, if we draw a line from this crest to this crest, then guess what? We have a wavelength. And how about drawing a line from this trough to the next trough? What do we have here? If your answer is a wavelength, then good job, you're right. Let me just remove some of our annotations so that we can focus on the wavelength clearly, right? Now, what if we draw a line from this point going to the next point? What do you think? Take note that these points are not crests or troughs because these points are not the highest or lowest points. Can we still say that this is a wavelength? If your answer is yes, then let's add something to the earlier definition. It says that a wavelength is also equal to the distance between any two identical points on successive waves. Okay, let's repeat it again. A wavelength is also equal to the distance between any two identical points on successive waves. Now, let me elaborate. If we create another line, the blue line parallel to the resting position, this one that I am pointing at, whose length is equal to the crest-to-crest wavelength, meaning the length of this line has the same length as this line. In Filipino, magkasing haba. Alright? Anyway, I mentioned parallel. When we say parallel, that means that this line is just as straight as the other line, and both of them point in the same direction, and those lines will never ever touch each other. They will never ever meet. Alright? And we move this line down such that its both ends touch any point on the waves. Then we can say that it is a wavelength simply based on the given definition, right? The same is true if we move this line up to the resting position. Therefore, going back to my question, if this line is a measure of wavelength, the answer is yes. Alright? Now what I just want every one of us to understand is that measuring the wavelength is not limited to measuring the distance between two successive crests or between two successive troughs. We can actually measure the wavelength from any two identical successive points on a wave. But for simplicity, we commonly measure the wavelength from one crest to the next crest or from one trough to the next trough because these points are easily distinguishable. Can you follow, class? Great. It is important for us to understand these two characteristics of waves for us to appreciate that waves are carriers of energy. This means that whenever there is a wave, there is always an energy associated with it. Alright? But how does this happen? Remember that keeping the wavelength constant, the amplitude of a wave is directly proportional to the energy associated with the wave. What does it mean? This means that the taller the amplitude, the higher the energy of that wave. And the shorter the amplitude, the lower the energy of that wave. Did you get it, class? Let me show you a question. Among the figures I showed you a while ago, which do you think has the highest energy? How about the lowest energy? Again, remember that the amplitude is directly proportional to the energy. Do you have your answers now? Great. If your answer is that letter A has the highest energy, then you are correct. And if you answer that letter C has the lowest energy, then you are also correct. Good job, students. But why is that so? It is because the amplitude in A is the tallest, therefore it has the highest energy, while the amplitude in C is the shortest, therefore it has the lowest energy. Let us try to apply this information in real life. I am holding my guitar right now, okay? And you can't hear any sound coming from my guitar because I'm not doing anything with my strings, right? This means that the status of the strings is undisturbed. I'm not disturbing the strings, alright? The strings are not creating any waves, any vibrations, okay? Now, if I strum the strings gently like this, I am transferring a minimum amount of energy. Okay, remember, minimum amount of energy. And when I do this, I transfer a minimum amount of energy from my fingers to the strings. So the strings will start to vibrate. And once the strings vibrate, the strings will send sound waves to the air that you can hear. Okay, again, this quieter, softer sound corresponds to a minimum amount of energy that I transferred. Okay, now, if I strum intensely like this, you will hear a louder sound, right? And this louder sound corresponds to a greater amount of energy compared to what I did a while ago. Okay? I am transferring a greater amount of energy from my fingers to the strings, so the strings will start to vibrate and the strings will send sound waves to the air that you can hear. Okay, more of this will be tackled when we talk about the characteristics of sounds. Okay? Now, how about wavelength? Remember also that keeping the amplitude constant, the wavelength of a wave is inversely proportional to the energy associated with the wave. What does it mean? This means that the longer the wavelength, the lower the energy. And the shorter the wavelength, the higher the energy. Alright, again, what is the relationship? It is inversely proportional. Unlike in amplitude, wherein the relationship is directly proportional. Alright, let me ask you another question. Among the three figures, which do you think has the highest energy? How about the lowest energy? Again, remember that the wavelength is inversely proportional to the energy. So when one increases, the other decreases, and vice versa. Can you now answer the question? If you answer that C has the highest energy, then you are correct. And if you answer that B has the lowest energy, then you are also correct. Excellent. It is because, do you know the answer? Alright, it is because the wavelength in C is the shortest. So it has the highest energy. Right? And also, the wavelength in B is the longest. So it has lower energy. Okay, it's nice to know that you're getting into answering these kinds of questions. And for us to have a pretty good comparison, this is the wavelength of B and this is the wavelength of C. The one which is longer, which they think is longer. Alright, so B is longer. It has lower energy. While the one which is shorter, which they think is shorter, it is letter C, right? It has higher energy. Alright, I'll show you another real life application. We have here a blue fire and a red fire with their corresponding wavelengths. Now, class, I want you to remember that light travels as waves, but we will talk about it more in the succeeding lessons. For now, it is enough to know that light travels as waves. Alright? Given those wavelengths, which do you think has higher energy? Is it the blue or the red fire? Again, just look at the wavelengths. Alright? If you answer that the blue fire has higher energy, then you got it right. It is because shorter wavelengths in blue fire means that the energy is higher. Why? We just need to remember that the wavelength is inversely proportional to the energy. So as one becomes smaller, one becomes larger. Alright? On the other hand, the red fire has a longer wavelength. Therefore, it has a lower energy. Alright? I hope that I made it clear to you, class. We are done with the discussion about waves, its characteristics, and the relationship of those characteristics to energy. Now we're going to answer the pre-test that we ran through at the start of our lesson. Okay? Number 1, what do you think is the answer? It is letter C, right? We know that what is being described here is waves. And it is in fact the definition that we worked on. Alright? Number 2, it is letter D. Again, if there is no disturbance, we represent a medium like a flat line, which we call a rest position. Number 3, it is letter B, right? We know that this red line measures the displacement from the highest point down to the rest position, and this is the amplitude. Number 4, it is letter B. We also discussed that the longer the wavelength, the lower the energy associated with it. So B is the answer because it has a longer wavelength. Alright? Number 5, letter C. Again, we can measure the wavelength through successive points of waves, and letters A, B, and D satisfy this. Alright? Well, C is not a wavelength measurement because it is the measure of amplitude. Number 6, is it true or false? The answer is false. This question is like a formal statement of the previous question, and we learned that measuring the wavelength of such a wave is not limited to successive crests or successive troughs. we can actually measure a wavelength between two identical successive points of waves. Let's just go back to this figure that I showed you a while ago. We can see that in this wave, we measure the wavelength from one point to the next identical point without measuring the crests and troughs, right? Number 4, true or false? Number 7, true or false? It is false. This is because the red line represents, yes, the wavelength. Number 8, true or false? It is true. Again, the shorter the wavelength, the higher the energy associated with it. So, can you recall the relationship? It is inversely proportional. And as you can see on the illustration, the longer the wavelength, the lower the energy associated with it. And a good way to remember this is that longer and lower both start with letter L. So longer wavelengths go with lower energy. Alright, meanwhile, the shorter the wavelength, the higher the energy associated with it. Number 9, is it true or false? It is true, because the higher the amplitude, the higher the energy associated with it. Hence, the relationship is, can you recall the relationship of amplitude and energy? It is directly proportional. And as you can see on our illustration, this one has a higher amplitude, thus it has a higher energy compared to this one because this one has a lower amplitude, which is associated with lower energy. Alright, and lastly, is it true or false? It is false. We knew that waves only carry energy, not matter. Again, just remember that waves only carry energy. Waves do not carry matter. Maybe the particles will sort of move back and forth, up and down a little, but they are not actually transported by waves. Now, we established a while ago that sounds are actually waves when I demonstrated it by playing guitar. Alright? If the person on the right speaks with the person on the left, then the person on the right sends sound waves to the person on the left, right? Do you think that when the person on the right speaks, the sound waves will carry the flower vase to the person on the left? Definitely no, because the sound waves carry energy. Sound waves do not carry matter like the flower vase. The essence of this illustration is that waves do transport energy. Waves essentially do not carry matter. Don't worry, you will realize this more when I showed you the assessment that you can try at home. Did you get all the answers correctly? Congratulations, I knew you could do it. And if so, let us know in the comment section. If you did not get a perfect score, that's also fine. At the end of the video, I'll present different assessment activities which will enhance your understanding about waves. Alright? Now class, I want you to know that waves are not limited to tsunamis or waves in the sea, just like what we talked about at the start of the video. There are also occurrences in our physical world which are manifestations of waves. For instance, the microwave oven we use to heat our food utilizes waves. The colors we see are manifestations of waves. An earthquake is a wave, and your favorite songs and sound waves that you can hear. More of this will be discussed in the succeeding lessons. Again, just to sum up what we talked about, we learned that a wave is a disturbance that moves away from a source carrying energy with it. We also knew two of the most important characteristics or properties of waves, which are wavelength and amplitude, and I also demonstrated the relationship of the two to energy using a guitar and light. Lastly, we discussed waves as carriers of energy, wherein we used two examples, one using a guitar and one by comparing colors of light and their corresponding wavelength. Alright, that would be all for our lesson about waves and its characteristics and the relationship of those characteristics to energy. In this lesson, here are my references. I hope that I made it clear to you, and let's continue to enjoy learning because science brings a lot of fun. I believe that practice makes a habit, so you can check our website, PhilSciHubEd, and there's a link of your assessment activities. We have a wavy anatomy, I wanna be wave you, tama behavior, go or don't go with the flow, and we've been there before. And also shake it rope, shake it rope. It's really a lot of fun. Of course, don't forget to visit and message us on our social media accounts www.philscihub.com, at philscihub on Facebook, philscihub TV on YouTube, and at philscihub on Twitter, Instagram, and TikTok. Thanks so much for watching, and I know that we all learned from this lesson. I am Kirby, one of your Filipino Science Lab teachers, and I'm glad to help you learn.